Yeah.
Perfect.
Okay, we are live now. Hopefully.
So, do you want to say something or start?
Should we say something? Just welcome you, Damien. Welcome back. You're the second time here, right?
Yeah.
Cool. Yeah, nice talk about Facebook and core security. I currently need that topic, so that's also a reason why I invited him. Yeah, thanks for coming. Yeah, start.
Okay, quickly, just a bit of myself. I do a lot of open source work. My favorite technologies at the moment has been core, Angular, and security. And I try to focus only on ASP.NET Core and do less and less Angular if possible. Angular is brilliant, but I prefer doing ASP.NET Core at the moment. So. And luckily, I make the change lately because if you do security, you pretty much do what you want. Everyone needs security. So today, it's quite difficult to choose what to talk about because there's so many different topics in security. And what I try to do is I try to give an overview what you should use when and why you should use that. But everyone hopefully has an idea. I use this application, I should do the security this way, and this is the problem I need to solve. So hopefully at the end, everyone will have something to take home with them and a better idea of how you should do your security for your web applications, mobile applications, native applications. I can't go into detail in anything because otherwise in 3 or 4 days to do the topic. I'm going to start doing a course as well, someone which I do 3 or 4 days, which will break up all the pieces of this, especially that detail. So first I'll just talk about what security, how the applications would look nowadays when you're doing a typical application. Then the modern specifications which you should be using now are for any new projects, you see OpenID Connect and OAuth2. And then a bit about protecting APIs because everyone's problem SPAs now, Angular or Vue or whatever. Then I like to talk about the authorization, how it's solved in ASP.NET Core. I think it's brilliant. It makes it really easy to implement your authorization. And then about web security, so test tools and data breaches. Just roughly the top 10 level. So, first of all, usually when you start a new application, you have a person who wants to do some business, you have an application. So what usually happens is you implement everything in one application. You have your authorization, authentication, authorization, the business, the reason why you're making the application, plus the data access data where you persist the data. So it usually starts off that way. And then suddenly it's a success, and then you do a second application. And then you've duplicated all your authorization, authentication, and identity logic. So how these authors go, usually have a mobile phone and your web application success. So you don't want to reuse or re-implement the same logic. So how a typical application look nowadays, you have your user, and then you have your client application. And then you have your APIs that have the data of the business and you split it up. And then you have maybe a second application. So with this then, in the SDS server, it's called the Secure Token Service. That's usually what everyone has nowadays somewhere in the company. Because if you have Azure AD, Office 365, or you have the Identity Server 4, you will have an SDS server somewhere in your company now. So the best thing is trying to reuse that, and then you don't need to implement your accounting again. Every application can use an external server, or if you don't need that, you can use it all together in one with Azure authentication authorization. So what happens is, first thing you should always do is you have HTTPS everywhere, even by development now. You should never use HTTP anymore. In the old days, we used to put up a WAF in front, and behind the WAF was HTTP, and in front of the WAF then it was your HTTPS. That's old school. Now you have HTTPS everywhere, also in development. So the first thing you do when you set up your new development environment is your Angular as well, or whatever, is HTTPS. Most people don't do that. Then the second thing you have to design, when you do your application design, is you have to plan your WAF. And that's a web application firewall. And what you do is you have to decide which applications are inside your firewall and which applications are outside. And this makes a huge implementations changes up. I'd say, yeah, okay, so if my application says inside or outside the WAF, it's allowed to access different types of resources, different types of data. And what that means then is For example, what I'm showing here is a client application. It's a trusted application because the backend is hosted by me and controlled by me. I can trust it, which means I can access the resource server as I want. But about this situation, the client application is outside the firewall. I can't trust it. This will be an SPA application, which means there's no trust. They can access the public resource server, but not the ones in the private zone. So I have to use different tokens for the ones in the private area or the protected area as the public area. So depending on how you set your off your zones, you use different security flows. Because when you're designing web applications, you have to also design the security models. So with every single application, what you have to do, you have to solve the authentication, you have to solve the authorization, and you have to solve the accounting. Usually you can reuse something if you have the Office 365, but usually every application needs that. Then you have session protection, and that is, you say when you log in and log out, in between is your session, and you have to protect your web application during the session. And there's different ways of protecting it, and most people forget to do that bit. Then of course you use proper certs, TLS, you don't support SSL anymore, use 1.2 of Fossil, that's been released now. You use up-to-date certificates that don't go wrong, and then you should also use the IP security still to go off.
What do you mean by accounting? Sorry.
And managing your users.
Right.
For example, if I have Office 365, your company does that, and then I don't need to manage it. I hope they can reuse that through our OIDC interface.
Okay.
But if you do everything in your own application, you have to do create user, register user, login, rights, roles, and all that stuff. But you have to have that logic usually because you don't usually have just one user.
Since you say HTTPS everywhere, even in development,
Yeah.
what do you use for a certificate while developing a real certificate or like a self-signed or what?
I usually use self-signed, but if I can, I use a real certificate as well. But a real certificate means you have to have a public DNS. And if you're using that, then sometimes it's difficult to, I would say, every developer can have that. So usually what I do is I develop my IIS Express, and then I just add the self-sign for myself. Everything will be tested then, but in browsers, then you don't have to secure signal, but it's fortunately work with HTTPS, which means I can't load the image to HTTP, for example, which happens when I don't do it that way. Well, what's the typical flow? To say, when you have a web application, the first thing you usually want any application, the first thing you usually do is you have to authenticate, two-factor authenticate or whatever. Then you have the session when you're running. And then at the end of the session, you usually have to log out. Nearly every single session application, you have this, okay? So different parts of the application lifecycle is you protect it in different ways. So first of all, I go through the standard specification. If you're doing a new application, the recommended and best way of doing this now is OpenID Connect with OAuth2. Okay, all the other ways of doing it are legacy or not best practice. You should not invent security yourself. You should try and follow a standard. Not a lot of people invent something themselves always. That's wrong. So what is OpenID Connect? It's just an extra layer on top of OAuth2. OAuth2 is for permissions and access, but it does not provide any way of doing the authentication. And OpenID Connect is just a layer on top of the OAuth2. And with that, I can do the authentication as well as the authorization levels. Both of them together, they're not separate. So what does OpenID Connect bring, or OIDC, a lot of people say? It's a standard specification, which is not invented by me or anyone. It's a load of companies and big players came together and defined the specification. So if you support this in your application, you have a security interface which will work with nearly any other application server environment. It's a massive win. You don't have to fight the security implementation with every client. You just say, I support OIDC, and then the server environment and the client that uses it can say, we have that as well. Really, everyone has Office 365. We can connect into our system and use our users. So it makes it really easy to integrate and really use your application. Do you have authentication and authorization? Before OAuth had only authorization, now you have both. It's built on top of OAuth. It's identities is one of the biggest principles of OpenID Connect. An identity, just what is that? An identity, that is, an identity is not a person. A person plus an application is an identity. So if I use my application, that's one identity for me. But if I use a mobile application, it's a different identity for me, and I have different access rights in that identity. So it's not the person, it's the person plus the application makes the identity. Or it could be a machine, and a machine plus the application with the machine access the API is the identity there. It's an important concept because identity is getting more and more important with the Azure and the cloud solutions now. What it also does is it introduces a standard way of getting your user info. Before OpenID Connect, we had OAuth and extras from every single provider. And then the problem was that everyone got the user data differently. And what happens now is that we have a standard way of getting the user info. So by connecting with OIDC, I get your profile in a specified way, and then I have all the claims over you. It's really easy to reuse them. What's really cool about OpenID Connect again is it's connected and supported by nearly all the big players. You can use Azure AD, Azure B2C, Okta, Identity Server, and they all support out of the box OpenID Connect, I think. Node, you have an implementation in nearly every single language. If you go to the server, you'll see the implementation of OpenID Connect somewhere. Google, Microsoft, they all support it. So if you support that new application, you've got the security interface for every other application that you might need, except SAP maybe, or something like that. It's always difficult to do. So where does OpenID Connect come into play? It's only used for the login process, the authentication authorization at the start, and when you sign out. The bit in the middle is not covered because the session is protected a different way. So I protect my application at the start and at the end. Just some terms that comes with OpenID Connect. The ID token is what was introduced, and that's a token which you use for your application now. It's not used with the APIs. This token is just for the application and nothing else. And in this token is a JWT token. I open that in my applications, it could be any application, and that, in this application is all the rights and roles which is given to me, which I can use the application to show the screen, hide the screen, whatever. Also, is in that token is all the validation I need for the access token. Because it has signatures, and the signatures then have anomalies and states and everything, which then I validate the access token with. So when I give you an ID token and token at the same time, one token is used to validate the other token because the access token will not open. The access token then, or the token itself, is just for accessing data resources. The client application should never open that. It's purely for access. And then, when I receive that my client application, do nothing else is given on as a bearer token or as a cookie to my data server, and then I get the data back. You don't open any client application. Another token you have is a reference token. This is a super concept, but a reference token is a reference of an access token. And what this means is the danger is when I can steal your access token, I can use your data. So if you can stop people getting access to your access token, you're safer. So what people do is instead of putting the access token out into the internet, they keep the access token in the back end or the back channel, and I give you a reference token. And if you steal my reference token, I can kill the session much easier. I can manage it because the access token stays valid until it expires. I can't unvalidate the access token. The only way I can unvalidate it is to wait till it expires or kill the server. So if I use a reference token, I can kill the reference token and then I have no access, no reference of the access token at the safe again, or at the safe for.
So when does the reference token die after every request, or?
That's your logic, you can define it and use it however you want. Usually when I kill the session with a logger, I kill the reference tokens. It usually has the same life cycle as an access token. But what's good is that I can kill the instance, and when the instance reference is gone from the access token, then there's no way of accessing the access token, so we can kill it before the access token expires. So I can manage the life cycle better. Then you have a refresh token. That's only used in two flows, in the hybrid flow or the authorization code flow. And that's when I want long running sessions, for sure I want to log in and I don't want to keep logging in every 20 minutes or every hour, I can use a reference token that will automatically get me the new tokens in the background. And what it does then is the refresh token is used when you use the offline access scope. And when I use the scope, then automatically the flows will use the refresh token to get a new access token and the new refresh token. And this way I stay logged in the whole time. Scope is a way of grouping what you have, right? It's like a group of claims. Like I say, for this resource is one scope, this is two scopes. It's just concept that I would say, I give you this scope is what I want to see, and then the server decides if you allow access everything within the scope. Back channel, this is interesting. When I have two trust applications, there's a backend, a set entity, so asking on core entity application that has backend logic. And I have two of these backend logics, they're trusted. And if I was to send data from one of them to the other, that goes from my backend, part of the application to the other backend, that's back channel. And this is a much safer channel in the application because it goes from one of my trusted applications to a separate trusted application. And it's very hard to intercept that. And the front channel is different. That's what I send, for example, to an Angular application. That goes to the browser and the public internet, and everyone has access to that. Because it goes, not everyone, but it goes into the browser, which means it's less safe, it's not as trusted, and I have to treat it differently. So when you split up these, the front channel and the back channel, you can do different types of security solutions depending on what type of security you have. And then the user agent is used a lot. That's actually just a browser. That's wherever you use giving your information. So, what type of flows should you be using when you do a new application? For me, these are the only type of flows you should use, and any other security you do or whatever, I don't see a use case with. So there's three OIDC flows which you should use: the implicit flow, the hybrid flow, the code flow. I'll go into detail in each one of them, when you should use it and what it's used for. And then you have the OR2 resource flow, that's for machine-to-machine communication between trusted applications. For mobile applications, you should only use the native API PKCE Authorization Code flow and hybrid flow. Mobile applications should not use any other flow now. And then the last one, which is not yet finished, is still in draft, is the device flow. This when you have an Xbox or a browserless application, we don't have it's not easy to give inputs. You have in the Xbox controls or the PlayStation. It's very hard to give in a 20-character password, and after the fifth time you do it, you get tired of it, and then you make a small password then. So it's really hard to do a proper secure flow for login to PlayStation. So what you do is then invent this flow now, the device flow, which makes it, I'll go into detail on as well, makes it easier to do a proper secure login with your Xbox, whatever. Or it's for browserless applications. So first flow is the implicit flow. This is only for SPA applications designed. You should only use this for Angular, Vue, or React, or if you have any other browser-based applications. This is the only flow you should also use. An SPA is runs in the browser, which means untrusted. It's not in my browser, it's in the browser of the content. So any other type of security logic you do in an Angular application is not really the best practice. You should not handle passwords in an Angular application. The Angular application should say, I'm not logged in. Redirect the user to the SQL server and says, give me the password, log in after. Then you get the tokens back, and then all's okay. There's two types of flows as well as the ID token and token flow. That's where you have data, and then you have the ID token flow. I've never actually seen a use case with the ID token flow because you have no access token, which means you cannot access data. So I don't see any use case really for Angular application kind of data to access if needed. So how does it work? It's really simple. In your browser, you open up your Angular application. You do the Angular application notice that you're not logged in. You redirect to the SDS server. And then I'm no longer in the Angular application. I'm in the secure token server. Then I can give them my password, credentials, login, two-factor authentication, or I can send me on to my Azure ID or whatever. Then I come back then, and when everything's okay, it's redirected back to a predefined URL, back to the browser and front channel. And then the client then has to validate what tokens come back, and if all is okay, the application starts up then. And then the client libraries is specified exactly how you should validate the tokens you get back. There's about 15, 20 checks which every application should do to validate that the tokens that come back are correct. That's the only flow you should use for any of your SPA applications. Works fairly well, but it's the least safe of all the OIDC flows. There's no other way of really doing it because it's an untrusted application that runs in your browser, not mine. Then you have the code flow. This is the safest of all the OIDC flows. This is only for trusted applications. An M4C application is one of these, for example. This is where I have user integration. I trust the application, and my application wants to log in. So yeah, what happens here? I'm not logged in. Again, it redirects to the secure token server. It can do a federated security after that if it wants or not. And then when I get my tokens, this time it sends back over the front channel the code. And this is my access code. And what the application does then is it goes into the back channel, which is safe, and that has a trusted secret that only the application knows. And then it sends the code and the secret to the server. And then the server validates the secret and the code, and when both are okay, it returns the tokens back in the back channel and the refresh token if you have the offline access. And this way, it's really hard to hack this, or this is the safest of all the flows. And this is the way you should do every M4C application or hybrid flow procedure. This is the one I'd recommend the most on the hybrid flow. The hybrid flow is a mixture of the first two. And this is I can mix it in any way. And the good part of going to this is for web applications as well, with back-end logic. It's also trusted. What's good about this is when this time the only difference here is that in the step node 3, instead of just returning the code, I return an ID token for the application. And with this then I can set up the application quicker. I can do all the view logic and show all the stuff I need to show. And then the next request, then I go back and get with the code and my secret, I get the new token plus the new ID token, plus the reference token if it's, or the refresh token if it's requested, and then I can validate that again. But what happens is I can start up the application quicker and it's a little bit easier. It's not quite as secure as the authorization code flow, but it's yeah, I think it's secure. I use this one nearly always now for my M4C applications. Then this is the only overflow you should still use nowadays. This is for machine-to-machine communication in two trusted applications, but I have no user interaction. So a use case would be if I have an API and an API which has to communicate and send data between the two APIs, but they're both inside my trusted zone. I trust both applications. I have hosted both of them, they belong to me. So what happens is the one API needs to access the other API, and then I can get a token for that. And then I do this flow, there's also a credentials flow. I get the token back with my secret, and then I can access the data from the other API. There's no other use case for an overflow. Every other flow you should use an OID connect flow or OpenID. This is the only flow you should use for mobile applications nowadays. An awful lot of people are doing the security for mobiles incorrectly. It's pretty bad actually, the amount of people do it wrong. And if you're doing a mobile application, the problem is a mobile application of your phone is not safe. It's a native device that belongs to you. So the code is not hosted by me. It's hosted somewhere else. And that means if you have the code on your phone, you can open it up and you can find out everything on it. So this device is not capable of keeping a secret. Because of that then, I can't use the authorization code flow because I'm not able to keep a secret. And then the problem was, there's a hack a while ago. What happens is that people were using the authorization code flow, and hackers found out that if I replay sending the code, because in the logs in the mobile applications, you can see all the logs, and I can replay and send the code to the access server, I'll get the access token, and then I have your access token from your mobile application, and then I can do whatever the access token is allowed to do. So this way, you're able to rob data from your bank or whatever you did in your home. So they come up with this flow, and what it does is, at the first request in the front channel, it sends a code challenge, and that's a differentiated of the code verifier using an algorithm that both server and client knows. And then the second request, I send the actual verifier code, and then the server then uses the same algorithm to verify that when I do the differentiate value of the verifier and it matches the code challenge, I'll give them back the tokens. So I cannot replay the code. I can't send the code a second time, it won't work unless I have both. So this way it's not possible to do the man in the middle, listen to your logs and send the code again. This is, as I said, this is the only flow you should use for mobile applications. And it's got the library for app art, and that implements this for Android and iOS. And then there's no other actual mobile phone applications you need. An awful lot of people make the mistake is they use Ionic or Cordova in these frameworks, and you can't do the security properly with that, because how do you implement this secure if you're doing an Angular application and then you use this to produce a native application, and the security requirements are completely different. So you can't do it secure. So when I say fingers away from these strange things. If you want to do security properly, then don't use them. But maybe security is not important, but it should be. So if you do mobile applications, use Apport, and then it's pretty simple to implement it. And if you do a SAML for your mobile, you can also use the identity model for that, so it has that support. This is the new one, it's still in draft, and what happens here is that I don't have it's a browserless device, and I don't have a way of doing the proper input. So what happens is on the Xbox, whatever I use, I can click login, and what it does then, it sends a request to the authorization server, and then it says this person, this code wants to log in, and then they polls that. And then in the UI from your Xbox or whatever it is, it will show a barcode or some other way of entering your device. Then you take your mobile phone, you scan the barcode, and then you can log in with your phone, and you can use your key passwords or whatever. You log in, and as soon as you have a successful login on the SDS server, the tokens will be sent to your Xbox or whatever device it is. And then the authorization process is done and it's safe. So this is coming, but it's still in draft, but this is the way you should secure your new EOT devices with user interaction. So, but it's not yet quite finished, it's still in draft. So I'll show you a quick demo of the hybrid flow in ASP.NET Core, and that's roughly all of the OpenID Connect stuff I want to show you. If you do an application, you should always use one of these flows now. And there's no other use case for a different flow. Angular with cookies, for example, is not the proper way of doing things, or you don't use cookies with API. People invent so many different ways of doing security, and if you read the blogs online, you'll find more incorrect ways of doing it as correct ways of doing it. So it's important, if you understand, I'm doing this sort of application, I use this flow. If you use the wrong flow for the wrong application, it's also, you have holes in it. So is that part okay? Does everything roughly got OpenID Connect? Cool. Is the English okay?
Sure, yeah.
You could switch to German, but I'm enjoying the English. So the hybrid flow, how do you implement that in ASP.NET Core? This is pretty simple. You have the client application, and then you have the server application. And in the client application, all you have to do is you have when you're not logged in, so you have to log in using OIDC. Okay, that's the OpenID Connect middleware. And then when you're logged in, you have to save the token somewhere in your application. And usually you do this for saving this as cookies within your application. So what I have here is, you can see this, put it across. So I define the schemes that I need to use, and for login and log out, you can't see it because that's too big. The challenge and to sign out, I use OpenID Connect, and for the session bit, then the default scheme I use cookies. And that's it. Then, because of that, I'm going to save my login data in cookies. I need to add the cookie middleware, and then I have to find my hybrid flow connection logic. This is really simple. All I have to do is define the code flow, that is code ID token. That means I want the code and the ID token. That was the last flow I showed you. And then, because I'm using OpenID Connect, I'll send the scope OpenID Connect, obviously OpenID ISIS. And because of that, then the SDS server knows that you want to do an OpenID Connect flow that wants this hybrid flow, and then it checks if you're allowed to access the code tokens and so on. These scopes and stuff that are found in the client side in the application, or in my Azure RD as well, or whatever server I'm using, and that's all I need to do. There's one little special thing that happens, and an awful lot of people fall for this. In your M4C application.NET Core, you want to use the context.user.identity.name. And if you don't match the claim in your token, from the ID token, if you don't match that properly, then that'll be a null value and you can't use it within your application. So usually you have to map the name claim as well from the token that you get to what you get back. And per default, it's name with n rows, written large. So you have to sometimes use the email for your claim, sometimes use the name. Just you can use different properties for your name claim, just your default name claim in the application. And then there's one other little thing you have to do. You have to add the use authentication. Otherwise, when the callback comes from STS server, that's the second way I give you the code back in the flow. This is middleware that will have a /sign-in OIDC, and then this will take the code back and then send back a request to get the tokens. An awful lot of people forget this, and then you get the post back from the server, and then nothing happens. That's all you need to do of this client side. And then if you're using Untitled Server 4, and it's really simple, you can use your client configuration. And here I have an example of the client configuration. And all you need to do is you define the parameters. The ID has to match the ID from the client. You define which secret you want to use. It's not very secret. Usually, what I do is I have a production test environment. I set this in my automated build, and then this secret is every time different. This is very useful because if it's set in the build process, if I have a data breach after, I can change the keys of the secret straight away to protect against this. So I usually read this through configuration, so I've never set in code like this. And then you have to define which redirect URLs you'll accept, because it's predefined that not any application can connect, only the applications which I trust and allow. And that's one of the security features, that only that application with these hosted IP is allowed to connect as that client. And then the scopes that I allow. Here I have allow offline access. That means I'll send a refresh token back, and then you have to show me the consent screen. That's it. So when I set up the applications, then I have an authorized attribute on my controller, which means if it's not authorized, I have a program that will automatically show that authorized. So what you see is this crazy URL there, and what happened is that I'm on the STS server here. What happened was my client application says I'm not logged in, and then it automatically redirected the STS server with all my client configuration I showed in the OpenID Connect middleware. And now it tries to log in. I'm in the STS server, which is trusted. I could do a federated to Windows, I could do a federation to Azure AD, I could do a federated to Microsoft Live, I could do Google, I could do anything I want to. GitHub is also one. Then I can log in here. Then I get a consent page. This is part of the specification. Consent will always be shown because I ask for offline access, which is a refresh token. When I give my consent, I don't have to give it. Then I get redirected back to the client application, and that's it. Now I'm logged in with my name, and I can log out as well. So it's really simple to implement. I've got absolutely none of the authorization authentication logic required to log in, log out in my application. My application is much simpler now. And then I can manage that in a central place. Yeah, it's the wrong picture, isn't it? How do I make that big now? It's wrong.
Shift F5.
This is reset the mode. Just on PowerPoint. PowerPoint again. The minimum. Nice, thanks. So, protecting APIs. APIs is special. Two ways of protecting APIs. You can use bearer tokens in the API protector, or you can use introspection with bearer tokens. And bearer tokens, when I send you an access token to the API, the bearer token validation validates the token if it's correct, the scopes are correct, and if it's okay, then you're allowed access to the resource. Introspection sends it to your STS server. The STS server then validates the token, and if it's okay, then you're allowed access to the resource. And then cookies are not for APIs. You should use bearer tokens to validate APIs, because APIs are status definition. So you should not be using a cookie to access an API. If you just know that you use bearer tokens on APIs, you have come a long way. What I also do is I can split my APIs. I say I have public APIs and private APIs. And private APIs for me is something that's in my protected zone. And for me, it's really important that if I have a public application, it's not allowed to access a private API. I make sure that the tokens I give to the access tokens I give to the public API, a public application, will not work on my private application. I have my zone in the middle and use different scopes to validate that. So when you're doing your system architecture, your context diagrams, decide which is public, which is private, and then make sure that when you're testing it or you're doing your security model, that the public applications, APIs, the tokens used for that will not work for the private. That's one of the main things. This split the WAF really make the split. Policies and ASP.NET Core. This is one of my favorite features in .NET Core. Before in .NET, this was really complicated. Just as well, authorization is the process of you're already authenticated, and then I want to give you the authorization to say you're allowed access to permissions for this, this, and this. And this is the responsibility of the application. It's not the responsibility of the STS server or of something else. So my application is responsible for my authorization, but I don't have to implement the authorization in the application. What I usually do is I implement, if I have a microservice branch architecture, I have maybe 7 or 8 different applications. I want to put all my authorization into a central place. What I usually do is a simple .NET library or an assembly, and in that I have all my authorization rules. And then by doing this, then I reuse the same authorization everywhere. And if I'm doing, for example, a bank, every time I do an authorization change, I have to revalidate my authorization library. And then I use that in a central area, I can release applications without doing the validation of the authorization. What I try to do is avoid database as much as possible for authorization logic, because when you do an authorization, when I do a request, it gets authorized in nearly every single interface you have. Then you come to the controller, then you come to the next application, the next, all the applications authorize it. So if you're going every time to the database back and forth, you're going to use up all your resources and it'll be very slow application. Then you'll add caching, as usual, what people do, and caching is complicated. So you try to avoid the caching as much as possible. So what I usually do is I implement everything as code as far as it goes. And then I have pre-compiled authorization rules, which I can write unit tests for. And then only the stuff that is runtime, I put in the database then, because there is certain types of authorization that has to be read from the database. That's runtime data. So as little as possible in the database and most in code, which can be compiled and tested before I deploy. What's really cool is in ASP.NET Core, define the new way of doing authorization, and I think it's brilliant. What they have is you have requirements, policies, and handlers. And a requirement is a really simple rule. It's that you have to be 18 years of age, or you have to live in Switzerland. That's a requirement. Then policies. The policies then is how I use the requirements. I say if you want to use this controller, I define a policy that you must have this requirement. It doesn't say how to fulfill it, it just says you have to use it. So I put on my controller to use a policy, and I can use the policies anywhere. So you've already separated the policies and the requirements, and then the bit in the middle is the authorization handlers. And this is how you fulfill a requirement. Because there's many different ways to say you can fulfill a requirement. For example, just say to use my controller on my application, you have to be living in Switzerland. Requirement is living in Switzerland, and then the policy I say you have to live in Switzerland. And then to fulfill it, one authorization handler is that you have to have a Swiss passport. The second one is that you be a foreigner with a proper visa. And the third one is you have a refugee status. There are 3 different ways of fulfilling this requirement. So I have 3 different authorization handlers. I have my policies that just make sure you have the policy. And it's really easy to implement any type of authorization logic in ASP.NET Core. What's cool is it's no longer technically complicated to implement an authorization logic. Authorization is really complicated, but I can forget about the technical part now, I can just concentrate on the business. And to show you how easy it looks. Policy would look something like this. Requirement. I just say the person is an administrator. You see that? And that's a simple requirement. It implements the authorization requirement. More is usually not needed. So usually I define all my business requirements. So it is admin, you're 20 years of age, you're this, you're that. You can use parameters and everything there, but requirements are really simple.
Does that interface not have any members?
It can if you want to, you can add a property to it that say you have to be of 18 years of age, but it doesn't need it usually. Okay, then a policy could be something like this, or sometimes the authorization handler. The authorization handler implements the authorization handler with the requirement I want to fill. So I say this handler is admin, wants to fulfill this requirement, so we implement this class. There's two methods you have to implement, and then the handle a sync requirement. There's only one method you have to implement. And all I do here is that I say I have a claims I use for my tokens, and if the requirement is fulfilled, I use this business application method here. That goes to my rules, my implementation logic, which is every time totally different. Every application does this totally different. But I can just say, is that person admin? Yes, no, comes back. If it's okay, I say succeeded. I don't fail if it's not succeeded, I just go on further. Because the idea is that I could have a different authorization handler that says, if you do this, it will succeed, if you do this, it will succeed. If you fail it, the person is unauthorized, and then you get 403 or 401 back.
So you can register multiple handlers for the same requirement.
Yeah. And then to use this handler then, all I have to do is then register in my class where I want to use it. So it's hard with this text. So here I've added authorization handlers. And all I do is add it to the EOC, the IOC. I say this handler is added to the application. And now the handlers in the application, all I have to do is define the policy to use the handler. And I don't use the handler, I use the policy with the requirement. And you see here, all I do is say, I'm defining a new policy for me, and that uses this admin requirement. So what happens is when I use this, I go to my case admin controller. I say I want to use this policy. If you want to access this controller, you have to fulfill this policy. This policy says you have to fulfill the requirement is admin, and then all the authorization handlers which implement this requirement is a way of fulfilling the requirement. So if your user with the token you give has one of the claims which fulfills this requirement, or your business logic says that's okay, the requirement is fulfilled. And this way you can do any kind of complex authorization logic that's needed. And you've also separated it. You put your authorization in one area, and in the application you just say policy executes on Z. So I've really split it. It's actually a very beautiful implementation. I think it's much simpler as before. So you can really focus on the business now. You just use these mechanisms to have, and you can focus on the business of authorization, because authorization is complicated. And it's not the complication technically, it's with every business is really complicated. So I think this is one of the biggest and best features of ASP.NET Core, biggest improvements over .NET.
Can you show again where the handler, the requirement was instantiated, or is it ever instantiated?
It's just a class definition.
Mm-hmm.
And then I use it.
It was used just as a type argument. Then. Oh.
Now, I define a policy which uses it.
Mm-hmm.
So this policy here, I say I want to use this requirement. And then I can use the policy anywhere. You don't use the requirements directly in your authorization because you want to separate this logic. Then I only use policies in my application, and then the policies are implemented in central, and then I can say, for this policy, you have this requirement. And then I could have a different requirement or the same requirement with a different policy then, and then I can map the policies requirements any way I want. Because no authorization and no application is the same.
Mm. Just a contrast example maybe, but do you have access to the context of the request in that situation when you add this requirement?
Here?
Yeah.
In the handler I have.
Yeah.
Yes. Sorry. Yeah, because the context is stuff we need here. So, to the handler.
Yeah, just imagine you want to have the requirement that you can buy the cigarettes, and in one country it's from 16 years onwards, and the other country from 16 years onwards.
And then what I use then, the claims in the token in the context of the identity that comes with the request, use that then. See, I use the claims here. I have my context user, and then I can get all the claims from the user. And here I just check a certain claim. And if that claim is there, I can use the name from the context, and that's from the request from the context. And then I have all the information I need. So this is really quick with the authorization, just brilliant documentation on GitHub, and from Barry Jones, the really good talk about this in NDC in Australia last year. It goes through it in good detail. But if you do an authorization, go for .NET Core, and then authorization, and then...
That's Blow Dart on Twitter, isn't it?
That's not it.
Yeah. So he's the security guy in ASP.NET, isn't he? It's like,
Project manager.
when they always talk about security, it's always his name coming up.
Yeah. He's a bit mad.
That's quite nice.
But he's really helpful. They ask him, he gives you...
Well, you have to be mad to do security, isn't it?
It's the best part of software.
Yeah.
I'm looking at my screen again to share. What's this,
Yep.
Stop sharing, and I have the... Where's the screens go?
Shift F5.
Shift F5. Oh. So, that's the first part of the talk finished. This is all about the login, logout, OIDC stuff, and how you can implement .NET Core. Didn't go into detail in any part, because I can't take it this time, but do you have a rough idea how you should, your next application, which flow, where you go for? Or at least send me a tweet and I will give you a shout out. But roughly, that's the first part of the start session and the end of the session, login, logout. And the next bit of the talk I'm going to do, it goes, how do you protect the bit in the middle? You've got your tokens and now you're accessing your data, and what type of attacks, what type of problems do you have, and how do you protect against it? So, as I show here, authentication is signed up as okay, and the session in the middle is the bit where we're going to go through bits and pieces now.
Damien?
Yeah.
On the stream, we see your presentation mode, so we should disable it.
Just flip it. I'm going to do how we want to show. So, download secure files. One of the biggest problems with download secure file, you have a link to a file, and the file then you can't add a header which token it, which means how do you download that securely? And there's two ways of doing this. One way of doing it is you use a one-time token that if I want to download the file from the server, the first request goes to say, I would like to download this file, and the response to the request validates your authorization code, or your token, your cookie, whatever you use, and then it gives you back a one-time token, sends this back to the server, and then you can download that file for 30 seconds maybe with this link, and you can only do it once. So it's a way of not giving you access token in the URL, and you can still download the file. The second way of doing it is that in the URL, I put the access token in the URL as a parameter. And this way, when I send it per HTTPS, the parameter will be encrypted, so you can't attack it in the middle. But the problem is that my admins have to trust, because every time I send a URL with parameters, this will be saved in the log file, usually of the server. And if I have access to those log files, I have access to every single person's access token. And then I can use those access tokens as an admin. I can access everyone that's using my application. So for a bank, if I'm doing this download with parameters and the access token, I can use everyone's access tokens as the admin. So you have to really trust your admins if you're allowing access tokens in your URLs. So it's only safe on the server once we host it with the log files. You have to be very careful all the routers after, which belongs to the server after the encryption. So it's really important. You should not send access tokens in the URL if possible. And if you do that, you have to be very careful how you log it. Second problem is WebSockets. WebSockets have exactly the same problem as downloading files. You cannot send an access token in the header of a WebSocket. WebSocket is a single error. And the problem here is that the only way of doing secure WebSocket communication is that you add the access token URL in the URL. And then you have the same problem that if it's in the URL as a parameter, it will get logged in the server usually, or your log files will have the access tokens in there. So you have to be very careful what you log, how you log it.
Yes, this is only ensured if you use WebSocket in the browser, from the browser client to the Signal server. If you use a Signal R client, a .NET-based Signal R client, then you can use header.
Yeah. Okay. They're trying to find a solution where you don't have to do this as well. So looking up different ways of, but WebSockets is designed like that, so it's. Next one is cross-site scripting. This is where I try to inject my code into your browser, and then I get someone else to execute my code. This is usually the first way I try to attack your site. Because if I can get a cross-site script attack, I can build it to do a second attack. Usually will get control of your tokens and make you do something for me. And usually what I try to do is that I try to add something that you will then use in your code that belongs to me. So I try to inject my script into your browser. There's a typical way is that you have an unprotected website and you have an input form that doesn't encode. I give you my JavaScript and then it saves on the server, and then the other client that gets that back, a new item, for example, a car sales, will show exactly that JavaScript that I gave in. And if you have that, then I can write any JavaScript and the other client will execute my JavaScript for them. And usually, to do applications that protect against that, where you say anything that I give out from the back end of the servers is sanitized or is not HTML code or JavaScript code is not allowed. There's loads of different ways of doing the attacks. And lately, this is getting popular again because people are using NoSQLs that save NoSQL unencrypted and then give them back out again. Before, when you use an entity framework core, it does all this protection for you. So it's important that you don't give anyone but it's not possible to let people inject code into your browser, which can be played back for someone else. What's happened a lot lately as well is another way of doing this where you can inject in the headers of your requests. And then you can do is there's a cache poisoning. There's a lot of servers what they do is they cache your requests, Cloudflare and people to do that. And what happens is then, if I can inject, if you have an unused header in your request, I can try to inject my JavaScript there. And if this is unused, usually it'll validate it, and then it'll get cached in the server, and then the next person that goes to the server will get my cached response back, and then I have my injected JavaScript. And then if I get that injected, then it gives me the tools I need to do the next attack. Because at the end of the day, I want to try and do something with your access. So the protection against this is the same on policy. XSS headers is really good. You should add this to all your request responses. Content security policy is one of the best ways of protecting this. I'll go into that in detail, but you should always add a content security policy in your headers to all your applications now. And basic is really simple, but as it gets more detailed, it gets fairly complicated to find out everything that you can close down. But with a content security policy, you can protect more or less against anything in your client side. And XSS is really easy to protect that. And of course, encode and sanitation and all that. And as a content secure policy, you should all, if you're not using this, you should start using this. This is one of the best ways of protecting your session now. And simple things like you can block all mixed mode, you can upgrade all your mixed mode, you can add all these extra stuff into your content secure policy. So if I request a HTTP, force me to block it, I'll upgrade your HTTPS request. In the old days, you can still do this with the WAF. A lot of applications do it with a firewall, but you should also do this in your applications as well. And then like I say, I only allow scripts from my site. I only allow no inline scripts. I can do an Angular application that I can pre-compile, and then I don't allow any pre-compiled, non-pre-compiled inline JavaScript. And then it's much harder to do XSS attacks and so on. There's also a super tool for this report UI, because what it does then is when your clients are using it, it sends reports back to a server and it tells you what's happening on the client systems using your application. And then it helps you build up a really good CSV. CORS is not really a secure feature, but CORS helps you a bit to force the same model policies and only applications from this. But it's not really a feature because everyone can turn off CORS in the browser nowadays anyway. It's really easy to turn it off, so it's not really a feature, but I always turn it on anyway. This is where the attacker tries to get your identity. That happens a lot with cookies, where you have a cookie and I can inject my JavaScript or I get you to execute my link, and then you resend your cookie with my link, and then I go back to your site with your cookie and I can do stuff on your behalf. And with the way you protect against this is that whenever you respond to an anti-forgery cookie, M4C do this automatically now. With that, then I cannot replay or resend your cookie with my request because I don't have access to that anti-forgery cookie. You should only use cookies anyway in back-end host applications and not in Angular and solid systems. This is involved in HTTPS, should be used everywhere. And the way to do it is now there's a HSTS header now you can add. And what this means is if I request a site with HTTP, it goes to the server and the server says now you have a HSTS definition on your header. It redirects back to the client and says send that over HTTPS please. And then every single request goes only over HTTPS and never over HTTP. And you can force this then, which means it's not possible to send a HTTP request. Because some servers support both. And you don't want to support HTTP, you just don't want to do it anymore. And the problem with this is though, the first request is still possible to send as a HTTP. That means if I'm trying to rob the bank data, which is interesting, or your insurance statements, which is also interesting, I will try to inject the very first request from you. So what happens is that you can preload the browser to tell that even from the client browser, the HSTS preload, I register my site to say I want to preload this site. And then when the client sends a HTTP response request to your server, the client browser itself will redirect locally to HTTPS, and then you send the very first request to HTTPS and not HTTP. So you're totally safe then. So if you're doing something really sensitive, you should preload your application as well. But it's good to preload AppSpot, you can register your website there, and then after a while it'll come into all the browsers.
What's the max age setting do?
Sorry?
The max age setting?
That's it. It forces you to use HTTPS until that's expired. So once you have it configured once, you can no longer use HTTP on your client browser until that expires. So usually you can say for 1 year or 2 years. The problem is if you do development and you want to use HTTP after that, you can't. But it's good. You use HTTP anymore. Then also force HTTPS everywhere. That's pretty obvious. You can have middleware that only HTTPS is in your application. This is one that a lot of people forget. You should protect your CDNs. Everyone uses CDNs to save you resources now. And one with CDNs, if you use a content delivery management system or a network, that means you trust them. And what's to say that they will not get hacked and start delivering unsafe content? That happens an awful lot. So you have massive security in your application, and then you have loads of CDNs you're using from jQuery, you're using this place, and you don't protect using it. So what happens is if that gets hacked, then your site gets hacked as well. And there's a really famous one in England about a month ago where one of the content delivery networks was actually hacked, and the fellow who did it, he put a Bitcoin miner into this content delivery network, and then every single person that was using this content delivery network got the Bitcoin mine in the browser application. So half of all the applications in England, then BBC and all that, were using Bitcoin mining for this person there. So he's getting free Bitcoin mining. And the way you protect against this, and you should always do it, is you use an SRE definition, which validates that library has not been tampered with it. Exactly the library you want to use is the one that you've defined. So if I was to add my hacking, what I usually do is in the script, I add my script after it, and my website browser will reject it, and then you can't fake it. So if you're using CDNs, you should always use the SRE bit or the SRI bit.
It's like some hashing or something like that.
It's it's like a code hash value of the whole script. So if you change the script, the value no longer matches, and then the browser will reject the script. You can generate it yourself as well. System hijack is mainly a problem with cookies and SPAs. People, for some reason, use cookies and SPA applications. You should use tokens to protect against this. And if you're using cookies, then use same site only and HTML only as well. You can divide the properties in the cookies, so it's not so easy to reuse it or hack. This is an open redirect. If you allow redirects in your applications, you can force them to only relative redirects is allowed, somewhere relative to your application is allowed, and not a completely different site. And you can force that, and it protects you against people redirecting to their phishing page or whatever. So you can add this property is local redirect to your .NET application, and then it protects against this. This is interesting. An awful lot of people make the mistake because it's, you know how you have crude operations, and maybe one property is called the isAdmin, and then you don't want to rewrite your details for update, delete, insert, get, so you just leave your isAdmin in, you don't use it, and then someone figures out that if I set the isAdmin for my property, I become an admin if it's not checked to the server, because I do an update and I set my isAdmin, then I'm an admin as well. And most people protect against this, but the way of protecting is you don't add in any extra properties into the request that you want to do, or you try to split up your crude operations. If you do the update and you only add the properties that's needed for update, that's not the same for the get. But sometimes it's annoying because then you start generating loads and loads of details. But you should only give out in the detail what's needed. And then you can protect against it. And then also on the server, anyway, you have to validate. Sensitive properties should be validated in every request, and not just the ones you use. This happens quite a lot, actually.
Mass assignment, yeah. That previous one with the, where do you use that? In the configuration or?
Yeah.
Okay.
It's written in docs, well, the Microsoft, I have a link there. I'll give you the slides after, and then you just add it to your class and start it, then you have it. This is also one. Any links in your browser, you should also add the no open and no refer to the link, and that prevents against phishing. Most people do the no refer, a lot of people forget the no open now. You should all add that. Any links you have in your browser to different websites and stuff, you should add that. Prevents against phishing. This is a cool one, unprotected APIs. So many APIs that you use in your public internet sites now don't have an authorized attribute anymore. But people forget to put the authorization on it, so you have public APIs with no authorization on it, and people think because no one knows where it is, it's okay. And this just makes no sense. Anything that's public has to be authorized. And there's a super website, Showgun now, where it goes through every single public API, and yet all over the world you can find out hundreds of thousands of APIs which are protected. And it shows all the features that have no protected APIs. So Swagger as well, there's loads of APIs with Swagger. And Swagger gives you a super documentation how to use the APIs. And then all the Swagger that are unprotected ends up in this website eventually, because it finds them all the Swagger definitions with no authorization. And then you can play with it and find out what you can do with these APIs. There's loads of APIs public, especially with the EOT devices now. There's loads of EOT devices which are public facing. So if you do a public API, it has to be secure. And this just makes no sense. This happens an awful lot now. And also, this is not really possible to pass with .NET Core. You can still do it with .NET. You should never mix cookies and token authentication authorization in an API or authorization type. You use one or the other, not both. If you're doing an API, you use tokens anyway. But if you're doing some type of logic, only go for one scheme. Don't use both in one application. Cookies, if you're using cookies, HTTP only, same site if possible, and then session cookies only. This is typical that you can't access from JavaScript and so on. Then the help disk is a library called nwebsec from NuGet. You can download it, and it will add all of these headers that you need in your application, and it's really simple to configure this. So if you use this library, you can configure nearly all the session protection you need in your application. You can add it in CSP pretty easy in .NET code. You don't have to add it in config files. You can program this in .NET code, C#, and you can add in your CSP policies, your iframe protections, and all the stuff you need. One I forgot as well, is iframe protection as well you should add in. If you're not using iframes, block them. And that protects against clickjacking. I forgot to mention that.
How do you block them?
Sorry?
How do you block them?
You can add iframe header in the responses, and there's iframe, iframe options, the header, and it's set to none. And that way, it's not possible to use an iframe in your application, because if I use iframes, then it's possible to do clickjacking attacks. So, test tools. Protect against the session is to use session headers. You can test any of your websites here, and you can validate if your website is safe or not at the headers. Most people don't have the session headers in the application. And then with this, you can see how good your website is. Actually, I'll do it then. We're in Basel. I'll do extra data. So So here's the site, and then I can give you any site I want here, and then I'll validate how good the protection this website is. So I take FC Basel, I scan it here, and then it checks for me. This FC Basel is really badly protected, it has nearly no session protection in it at all. It's missing the security transport headers, the content security policy is missing, it's missing the X-file protection, it's missing nearly everything. The only thing it has is I-file protection. So for me, that would give me, it's a good start. I try, there's possibly holes in this website that I could try and hit them. If you're in front of this site, you should actually fill this out. So if I open up the website and I have a look at it and see what's else going on. So if you were to implement the XCBAS website, you'd go and fill these headers now. Who did that? Then also have a quick look at what type of elements we have here. I go to the code here in XCBAS, and then I look at the headers. Check the scripts, and it's missing all the SRE bits. That means that if there are any of these scripts which are unsecure, if I was to attack this website, I would maybe have a look and see if I could override one of these CDNs that's used. Might be one that's not really safe or one protected. And that way I could maybe get my script injected. And also, yes, it's using Cloudflare. Doesn't mean you're using session cache. You could also see if you're using any unprotected headers, and maybe you can inject the script into one of the unused headers. There's different things here you can have a go over. If errors in the code, you're using a login straight away here. That means you can try and fish the login. See, you always want to log in here, so you have to use the login system. This way you go, you try to see what's open, what's not protected, and then I have a go and have a look at the site. But you as a developer, your job is to close all the holes. And security is not just one thing protects this. You have to try and protect everything. And what you do in security is there's 10 ways of protecting everything. And when you're doing your application securely, you try and close all 10 of them. And then if one of them fails, the other one is still protected. It's not like you say, I protect this with this, I protect this with this. You try and protect everything you can. You do the application hardening, and then you do the firewall hardening. There's probably a firewall that protects the headers here as well. But the two together, so if one of them fails or is programmed badly, the other one will save you. Because usually when you have a security leak, it's 5 or 6 different things fail, and then you leave one hole open. So you should close everything down that you don't need. Okay. So I'm going to share my Shift F5 in a second. This is a super tool. This is not so old now. This is for helping you build your CSPs and finding out what's happening in the browser, clients from your people using the application. Okay, when your clients are using applications, a big problem is you don't know actually what's happening in the application, the client that's using your browser. Because when you use it, it's in your servers and your piece and computer. But when they're using it, it's on their browser, on their computer. So you don't actually know what's happening. And with this tool, then it sends reports to this server. And then you can collect information of how and what's happening on the computers and the browsers and the clients, and then it can help you build up a really quality CSP or improve the security. This is for testing the certificates. If you want to test and see how good the certificate, you can give it an error, and I'll give you an ABC. And if you're using SSL, it will complain. And if you don't have your CAA name engine, you can protect with CAA DNS. If that's missing, it will tell you should go and register yourself on your website. It's very good, it gives you good reports. You should test yourself for that. It's the same as before, and it's another way of testing the browser headers. This for testing your tokens. When you're using bearer tokens, you can open up all the bearer tokens and then have a look at what's inside the bearer tokens, and then you can see the claims of your development, you can see what you're sending back and forth. Maybe you're sending too much tokens, maybe you're sending not enough. I use this an awful lot when I'm adding the profiles of the data to my tokens, which I need. Then the last bit, really quickly, data breaches. When you do new applications, it's really important now to plan for your data breaches. You should say, I'm going to get hacked, I'm going to get robbed of my data. And if you have this attitude, then you plan, what are we gonna do when this and this and this happens? So, one of the first things to do is say, if my data is robbed, or if someone gets access to the database, how do we react? And then you have to say, within 24 hours, you do a public statement to the press, say, we have a data breach, this and this has happened, you close down the website, or whatever. And if it's a small hack that maybe someone got access but there's no data leak, then you do still a public definition. But you have a process defined what you do, because when a data breach happens, your boss is usually blaming you as a developer, or someone has to get blamed usually. So if you have a process to protect all of you, say, when this happens, we do this, when this happens, we do this, you do the public statements correctly, the public communications, and you're ready for the, how to say, you're ready for it. You might have to take your website down for a few days until you fix it. And then comes the second bit, you should always add a security text to your server now, because if you have hackers, a lot of people will actually hack your website and then they'll write a mail to you now and say, you have a hole there, this is wrong. And if you have a security text, it gives them an easy way to contact you, and then you can say to them, thanks a million for this, we fix it, and could you wait for going public until we have it fixed? And then it's grand. And then once it's fixed, then they go public, and then you can do a public announcement and say, yeah, we have this problem with the application, we've no information that anything was wrong, but this was possible, and this person found it first, thank you very much, you can pay them money if you want to. But it's a really good way of helping the community help you. There's an awful lot of people do this for a living now. You can also register your website to say, please hack my site, and if you find something, we'll pay you a bounty. And then instead of waiting for the hackers to do it, you can get people that will try and make money off it. So it really helps to build up a security website without actually, it's free testing it. But you have to be public about it and let them take credits as well. And then something really important with data breaches, I think, is it has to be possible to do really fast builds. If it takes 3 weeks to do a deployment, you have a problem. That means if something goes wrong, you have 3 weeks before you can fix it with the fix time. So you should always try to make it as quick as possible to do a deployment. That means you have to have so much automated, as much automated tests and everything, that when the fix is done, you can click deploy, change security keys, all the secrets can be changed, and then you're back up and running as quick as possible. So it's really important for fast builds and deployments if you want to protect yourself against data breaches. Yep, that's everything. It's really fast site, but hopefully it helped you, so it wasn't so bad. How did it's okay? Any questions? I went over everything top level. I went into no detail anywhere. Whereas my idea is that hopefully you get a picture now, and then when you do your next application, you say, okay, I'll do this and this and this. And I won't invent the wheel myself. The identity server is super. It's become part of the .NET 2.2 framework. So the new templates will have identity server out of the box. So if you learn identity 4 now, you're doing well. And switch identity to core. Any questions then on any improvements? Anything I forgot?
I like the process.
When you were talking about securing APIs,
Yeah.
I mean, when you have a single page application, you often have your own sort of API for this single page application. So you're applying these things you've set to those kind of APIs as well.
Yeah, and then if I'm doing an SPA, I will use an OIDC Implicit flow, and I have my access token, my token. I use this access token to access the API, and then the API then, usually what I do is I validate against introspection against my SPS server, and then come back. But I never allow my SPA to handle passwords, so I'm using an STS anyway. And usually, what's popular now is Azure ID is getting really popular, or Azure B2C. I'm starting to use Azure AD a lot now, but I don't use the B2C that much. I use Identity Server 4, and then I federate to Azure AD mostly, because then I have full control over the claims for my application. And then if I need to add ABC in my tokens, which I can use in the API then to do the roles of the authorization logic, it's really easy to configure and manage it. That usually you need the flexibility, because what I noticed in the last last 3 or 4 years, every application I implement, it's over 6 months, it keeps changing totally the requirements and the authorization or the roles or how the applications are. Suddenly I have to connect in a new component. They never actually know what they want to do usually, and then it changes massively as what I thought was going to happen. And for this flexibility, I usually always need Identity Server 4 or OpenID Dict as well will work as well. But usually I like to have control of my authorization, which means I need to control my tokens. And with B2C, you have a certain amount of control, but there's predefined claims which you can use, and it works very good as well, but it's expensive if you have more than 50,000 requests, because every single authorization request after 50,000 you can pay them. Okay. But if you have low traffic or a small application, could be well worth the effort. So I've been working with that. Identity Server 4 is the next step, because I just showed the theory now, and Identity Server 4 follows the specifications really good. And I also have many examples for the later applications, as examples for the identity deployment is really easy because it's asked for the application. It's really easy to deploy it to Azure or to EES or to Service Fabric in Azure. Whatever your environment is, you can use it everywhere. And then if you do the federate into your company, it's 5 or 6 lines of code. Except if you're using an old AD, that's the problem. Then you have to use some type of SAML connection, or it's really difficult. And you've got really old AD FS. Most people have the 365 in everything.
Yeah.
Then it's peanuts. Okay, hopefully it was useful for you, Steph.
Sure. Yeah. Thank you.
Yep.
So we'll close the stream now.